The CMS Magnetic Field Map to the CMS Magnetic Field Measuring and Monitoring Systems. By Vyacheslav Klukhin, Austin Boll, Felix Bergsma, Henk Botrenbrood, Benoit Cure, Domenico Dattola, Andrea Guddy, Hubert Jervig, Alain Herve, Richard Lovelace, Gary Tifo, Daniel Wenman, Wolfram Zuner and Jerry Zimmerman. This chapter is the second part in a series of publications on the compact muon solenoid CMS detector magnetic field map creation. The CMS detector at the Large Hadron Collider has a heterogeneous solenoid magnet where the created magnetic flux penetrates both non-magnetic and ferromagnetic materials of the experimental setup. The chapter describes the performance of the magnetic field measuring and monitoring systems for the CMS detector. To cross-check the magnetic flux distribution obtained with the CMS magnet model, 4 systems for measuring the magnetic flux density in the detector volume were used. The magnetic induction inside the 6 meters diameter superconducting solenoid was measured and is currently monitored by 4 nuclear magnetic resonance (NMR) probes installed using special tubes at a radius of 2.9148 m outside the Barrel Hadron Calorimeter at ±0.006 m from the coil median XY plane. 2 more NMR probes were installed at the faces of the tracking system at Z coordinates of 2.835 and plus 2.831 meters and a radius of 0.651 m from the solenoid axis. The field inside the superconducting solenoid was precisely measured in 2006 in a cylindrical volume of 3.448 m in diameter and 7 meters in length using 10 three-dimensional 3D B sensors based on the Hall effect Hall probes. These B sensors were installed on each of the 2 propeller arms of an automated field mapping machine. In addition to these measurement systems, a system for monitoring the magnetic field during the CMS detector operation has been developed. Inside the solenoid in the horizontal plane, 4 3D B sensors were installed at the faces of the tracking detector at distances x is equal to ±0.959 m and z coordinates of 2.899 and plus 2.895 meters. 12 3D B sensors were installed on the surfaces of the flux return yoke nose discs. 70 3D B sensors were installed in the air gaps of the CMS magnet yoke in 11 XY planes of the azimuthal sector at 270 degrees. A specially developed flux loop technique was used for the most complex measurements of the magnetic flux density inside the steel blocks of the CMS magnet yoke. The flux loops are installed in 22 sections of the flux return yoke blocks in grooves of 30 mm wide and 13 mm deep and consist of 7 to 10 turns of 45 wire flat ribbon cable. The areas enclosed by these coils varied from 0.3 to 1.59 square meter in the blocks of the barrel wheels and from 0.5 to 1.12 square meter in the blocks of the yoke end cap discs. Measurement of the magnetic flux density in the steel blocks of the magnet yoke using flux loops and 3-dimensional B sensors confirmed the correctness of the magnetic flux distribution modeling in the muon momenta measuring system, which provided a high muon momentum resolution and a reliable muon identification. The development of the magnetic field measurement and monitoring systems and the results of the magnetic flux density measurements across the CMS magnet are presented and discussed in this chapter.